that we want to show you, like using the tools that we have here.
Recording paused, Mike.
It's paused? Why is it paused? It says it's going.
Oh, mine says paused. Weird. Okay, go ahead. Sorry.
Cool. So like we're going to teach you a number of different tools today, and they can kind of go in junction with things we taught you before. But the idea is that you can solve, there are many different ways to solve individual problems. And as you get a better, more experience and better at this, you'll get a better idea of which tools use your job. So right now, focus less on picking the appropriate tool and understanding how each one works. So the first thing we're going to talk about today is conditions. And the idea here is that we consider something that is either true or false as a Boolean value, right? And a condition is something that evaluates to Boolean. So if we do something like this in Pry, we can say play again equals false. This play again is considered a condition because it returns us a Boolean. And so this is kind of one example of condition. And the idea is that other conditions that we can create are by using what are called comparison operators. And we use these comparison operators to create a condition by comparing two values. You have probably all seen our good friend, the double equals. That compares what's on the left, what's on the right. I want to make a note here that it is the double equals because what does the single equals do? Single equals is the assignment operator. It's like a saying like, hey, whatever is on the right-hand side, you are now being put into the left like we did down here in Pry. Thinking back to our elementary / grade school / when I was very much shorter and younger math classes, we have things like the greater than, the greater than equal to, the less than equal to. One that you may not have seen that is relatively, I think, pretty much, I've only ever used in programming, the bang equals, which means not equal to. Right? And so we can use these operators like this, right? We can do set of a local variable called mood. We'll set it to hungry, right? And then we can see if mood hungry, or we want to see if this person's hungry yet. Do we have true? Like this is essentially me, I am always hungry. We could check if we are sleepy. And no, I'm not sleepy, I'm hungry. And we can also do things like we have a length method that runs on strings. So we can see if mood.length, we can see that is greater than 5. And that is true because hungry is 6 letters. We're looking greater than 5. We can see if I'm grumpy or not. Mood. Oops. Oops. And you see it's not grumpy, right? I think that, any questions about this so far? This should bring you back to the days when you were doing this, I guess, middle school, elementary school? The past is fuzzy. But you, like, we've seen stuff very similar to in math classes. And I kind of now want to add in this little wrinkle to it called the negation operator. The exclamation point, also known as a bang, will reverse something, whatever it is. So it'll return the opposite of what's returned. So let's say I have false, that's false. But if I do bang false, that's true. We had play again from earlier, right? That's false. But if I do a bang play again, that's going to be true. Cool. Ben?
Yeah, I think something that helps me kind of understand this is that as well in like I think we'll get into this, the Boolean logic and stuff. I like to think of the exclamation mark as like a not thing, as a not gate, so it'll just kind of invert. That's just kind of another way to think about it if thing is confusing.
Yeah, and the thing is that to be honest with you, I try to avoid using the negation operator, the bang, because I think for me personally, and I think for most people, we don't generally like to think in terms of negatives. We like generally time return. We try to think in terms of positives. Like, is this equal to this? Is A equal to B? And is A equal to not B? It's like you got to do that extra logical jump. And so I, in general, kind of avoid the not operator. And we'll see a little more examples of this in the future. Right. There are also some Ruby methods that can be used as conditions. Although it's not a rule, Rubyists usually end these methods in a question mark to imply that a Boolean will be returned. So we do one.even. That returns a false. We've seen include method that we use on strings. And so we do have conditional methods that are built into Ruby. Additional things that we have are the or and the double or and the double and. So these kind of combine two conditions into a single condition. The or operator evaluates to true if one of the conditions is true. So what we can do is if we do breed equals corgi, age equals 2. If we do breed double equals corgi, or age equals 2, this will return true. Both of these sides on the left-hand side of this returns true, and the right-hand side of this, I'm sorry, this should be a double equal. Do that again. Because both this side returns true and this side evaluates to true, the whole thing returns true. So, and the difference between the or and the and is that or requires one of them to return true. So if I change this to a 3, this will return true for me because one of them returns true. Right? And so to contrast with and will for both, it will return true only if both are true. So if I go like this and I change this to the double and, so this keyboard does not have the symbols of all the symbols on the thing. So I'm like, I don't know where these things are normally. And we can see here that this is false because the age is not 3, right? But however, if I change this to, nope, that's not the one I want to hit. The 2, where both return true, that's going to be true as well. Cool. Ben?
I just had a question on when you had the age equals 2, I was wondering why it didn't, spit out an error when you tried to do like an assignment in a conditional statement.
Because age, when you do age equal to like this, it returns true, and true is considered true.
Oh, okay.
We'll talk about truthy and falsy a little later on.
Cool.
Cool. So I think that, so the important thing about this is like be very specific with what you're calling conditionals on. And I would say, like, if you are ever, like, the thing is that sometimes you'll have to create complex conditionals, and I would recommend that you use parentheses rather liberally to ensure your order of operations. There is an order of operations with conditionals in Ruby, but to be honest with you, I don't know what it is because it is complex and very long. So I end up looking it up when I have to. And other than that, I just avoid making complex conditionals if possible and using parentheses so it's very clear what it is. I think that we all, we should all remember hopefully PEMDAS from our from our youth. And like even with PEMDAS, it's only 6 things. I have to work out like what's the P again and work through everything before I kind of figure that out. But the idea is that like the conditional order of operation is so much more complex. And I really recommend using parentheses so you don't have to like memorize that entire list. Cool. Any questions about these conditionals so far? All right. So with that, we're going to move on to conditional branching. And the idea here is that branching refers to a choice made depending on whether condition is true or false. It's very much like choose your own adventure. And to illustrate this, I have a music video, which I love. Did you all hear the music while I was playing during the break earlier? Okay, so I don't have to, that's recording. Let me turn off the recording here. And we are kind of going to show that this, how this works in Ruby. So the very simplest kind of way we can kind of go about this is a single branch conditional. And we can take this example of like, let's say we're trying to figure out, we're writing software for school and we're trying to figure out who's on the honor roll, right? If GPA is greater than 3.8, invite to honor roll. And this is a very simple kind of a one branch conditional. We look at the student's GPA. If it's greater than 3.8, they're going to be invited to the honor roll. And if it is anything that is not greater than 3.8, so essentially 3.79 below, it does nothing. Like what is inside between the if and the end does not get run at all. Cool. However, like I wish life was as simple as just everything being a either or kind of situation, right? But unfortunately, that's not true. We can add a different situation. So let us say we are looking at our budget and we're trying to decide if we want to eat out or not, right? And if spend that money is true, we want to fancy dinner. And if it is not fancy dinner, we can have it run something else. So I'm gonna use the else here and we do cook at home. If spend that money does equal true, we are going to run line 6. If spend that money equals false, we do not run line 6, but we run line 8. So this is a situation where you may have code in your application, in your method, and whatever that never gets run, right? And that's okay, right? Like we don't want, we don't want to write code in a situation where both branches get run, right? It's kind of, like in this situation, it is wasteful to both have that fancy dinner and cook at home. You can't do the two things. However, so in general, the kind of like the, oops, no, there we go. In general, what our code looks like for using conditional statements is that we have if, condition, some code goes here, and we have an end. In general, this is what our conditional looks like. All of our conditional branches begin with if, and the code following the if will run if the condition is true. We can also add things to it. We can also add additional branches to it. We use else if. So what we can look like this. If condition 1, code, else if, condition 2, code, else if, condition 3, code, end. And so what happens here is that if condition 1 is true, it will run whatever's in here. and then do nothing else. It'll just skip down past the end, and whatever is past there will go. If condition 1 is false, it will then check for condition 2. If condition 2 runs, it will, if condition 2 is true, it will run is what's in here and nothing else. If condition 2 is false, it will go down to condition 3 and so forth. It's really super important to look at the order of this. Also, we can also add an else here, and we also have some code with the else in the block of code in the else. It is generally good to have an else in a multi-branch conditional, because what if all the conditions are never met? We want to have something to handle that kind of situation. We want to, when we're building out these multi-branch conditionals, we want to think about like every single possible case, and we want to be writing tests to cover every single possible case. We want to make sure that like each branch is doing things properly. I also want to add that the order of your conditions is also super important. So I'm going to modify this, do something, and kind of like walk through this. If GPA is greater than 3.5, honor society condition. Oh no, that's the same word. GPA is greater than 4.0. They're going to be valedictorian, else if GPA is less than 1, we'll be else puts error, right? And this is, I think this is an example of why the order of these conditionals matter so much. Isabel, why do you think the order is important here? What have I done wrong here?
The order is important because that's Ruby is going to go from like top to bottom.
Mm-hmm.
So it's going to do like, I'm going to do this, and then if this is false, then I need to do this. So it's important to have that in place. And then what you've done wrong, not entirely sure.
Yeah, take a stab. Take a stab.
I don't know. I guess the only thing I can say is like, I don't really know what's happening with the code, in the sense of like, if I were a computer and you were like, here's this, run this, I'd be like, what am I putting something?
So what if I had a GPA 4.0? What would happen? What do you think will happen? What do you think actually happens?
So I would think that you're going to get a false for the first run. You're going to get a true on the second. And
why would I get a false for this one?
Because it is greater than 3.5.
Mm-hmm. So what happens here is that if my GPA is 4.0, this is going to be true, right? Because 4.0 is bigger than 3.5. So what happens here is that Honor Society gets run, and then it just stops. It'll jump down here. Valedictorian never gets run. If like the idea is that if my 4.1, right? If I have GPA 4.1, I would expect it to be valedictorian, but that doesn't happen. It just gets stuck at Honor Society, and this will never get run. Right, and this is kind of why like the order is so important, and we want to make sure generally how I describe to structure this is that we want the most restrictive conditional to come first, and it broadens out as we go below, right? Because like this with a 4.1 GPA student, it will be an honor student, not a valedictorian, where 4.1 is supposed to be valedictorian. James?
Yeah, just a quick question here. So if you leave the order as is, if you did if GPA is greater than 3.5 and GPA is less than 4.0, then it would work.
Yeah.
If you use the Boolean logic. Okay.
Mm-hmm. Yep. But this is just a quick example of like you like be very, very careful of how you structure your multi-branch conditionals. Cool. So important things to know about conditionals. Conditional branches there's only one if, and that's at the beginning. The if can be followed by any amount of else ifs. And the else is optional. I highly recommend having an else just to catch like an outside case you may not be planning for. We always have an end, and at one time we can only have one branch that can be taken. Right? You need to structure things in a way that only one branch will be run, and these conditions are evaluated in order. Cool. Any questions so far about branching? Adam?
Yeah, I had a question in the chat. I'm just was playing around in Adam.
Don't put questions in chat because like we're not going to see them.
Totally. That's why I raised my hand. Thank you though. But I was playing around in Adam, and if you don't put an else, does it, if it's true, I'm sure it'll run the code. If it's not true, will it still run the code because you didn't put an else?
It'll run, well, it'll go through the conditional, but if none of the conditions are met, nothing will happen.
Got it. Okay. I'll post this maybe in the Slack because I'm getting something different, but maybe it's something I'm not.
Yeah, put it in the
at.
thread and we can take a look
Cool.
at it.
Thanks.
Yep. Cool. Anything else at this point? Awesome. Let's take a break. Let's be back at 11:37, and we will continue. And the basic loop is a basic style loop is using the times loop, where we just do 5 times do puts hello. And if I run this, not quit, would be flow control. We see hello on the screen 5 times, right? Because we just did 5 times. It makes a lot of sense. And the times loop is great when you know that you need to run something just a set amount of times. We can also include a block variable. So we could do number. And so instead of this, do that, and we can see that it will know which kind of thing it's around. Any questions about the times loop? Cool. The next loop I want to talk about is the while loop. And so the generic form of the while loop is while condition. We have some code. And what's going to happen is that this loop will continue to run so long as this condition evaluates to true. Vanessa?
Yes, sorry, I was too slow. In the previous one, why didn't you have to set, to give number of value? Like why you didn't have to create that variable?
Because we're doing 5 dot times. So that whatever's in that block variable so when we do 5 dot times, it knows that I'm going to go 1, 2, 3, 4, 0, 1, 2, 3, 4.
Oh, okay, all right.
It's a feature of the times method that it does that.
Okay.
Yep. Sam, was that your question as well? I saw the hand pop down.
I don't know if I figured it out in my head, but my question was,
Sure.
Can you jump up more than like +1 numbers every loop? Like 0 to 4.
I don't know. I've never had to do that before.
I guess you probably don't
I'm
need to
not
do
sure.
that for the do loop then.
Yeah.
Okay.
There may be a way, I'm unclear. Liam?
Going back to what Vanessa asked, so I know it's going to do 0, 1, 2, 3, 4, because that would be like the places of whatever the variable would be that it's doing. But so it's just going to print like, I'm having a hard time formulating this question. Why wouldn't it just do like negative, like a empty space, empty space, empty space, empty space, empty space 5 times? Why is it like assigning like the place value as if it were like an array of 5
Because that's
values?
what times does.
Okay. Okay.
What the times does, it treats this, essentially treats this as if we're doing 0, 1, 2, 3, 4, and this was an each.
Okay.
Right? That's essentially what's happening under the hood, but it's like, it's so much easier to read times.
Yeah.
Right? The syntax of doing 5 times is so much simpler this way.
All right. That makes sense.
Cool. So going back to this here, the while condition will run until so long as this condition here returns true. So an example of this is that we just used, while parking lot dot full, keep driving. Oops. Right? Is the parking lot full? Yes, we keep going around. Is the parking lot full as in no, there's no spot, it finds a spot, then we stop driving, we park. Right? Questions about the while loop? Cool. Liam, then Karen, or was that the old hand from before, Liam?
New hand.
New
so
hand,
if you were
all
going
right.
to do while parking lot dot full keep driving, would you also add like an if statement after that inside of the while if you wanted it to like park whenever it got a new empty
No,
space?
the idea is that this is your if statement. This returns true or false, right? As soon as this returns false, it will stop. So essentially, instead of, I see what you're saying with the if statement, instead, like we would have the park. Ooh, that is nowhere near park. The park is outside of it.
Okay.
Right? So like when the parking lot is not full, this exits out and then we park. Right? The intent is like we're going to keep driving until we find a spot. We're going to run it. We're gonna park as soon as afterwards.
Okay, so specify it outside of that one. Cool.
Things that you need to be running while that condition is true go inside the loop. But like the idea is that like we're trying to like avoid conditionals in that case, like a branching conditional statement in that case. Karen, did you have a question, or did I answer it in the course of answering the other question?
You pretty much answered it, but I guess like, could you say that the while loop has an automatic like implicit return? Or does that not make sense?
The while loop doesn't return anything. It just does a thing over and over again.
Okay.
Right. Cool. The idea is that like the while loop will take place inside a method, but the method will do something after the loop. Right.
That makes sense. Okay.
Yeah.
Thank you.
Cool, cool. And so the next loop we're going to talk about is the until loop. And this is where I think it becomes very important to kind of think about like, no, that's why did I type 2? We talk about like what makes sense in our heads. The until loop is essentially the opposite of the while loop. So long as the condition evaluates to false, we are going to keep that loop running. So like to convert this, right, until we find a parking spot that's empty, keep driving. Because this is going to return false because the parking spot's not empty. And I see some people with some confused looks and like, yes, I'm with you. Because like you're trying to think about this problem from the opposite side and it gets kind of confusing because we're trying to do that in negative. Like here, we are driving while the parking lot is full. Here, we are driving until the parking spot is empty, which makes my eyes kind of cross a little bit. So the thing is that what I would recommend, like you can use either of these kinds of loops to do anything, but like my recommendation is like say it out loud in English words, whichever one makes the more sense, use that. It's more important that we're kind of clear. Sam?
I think my confusion is if I read it in plain English, I always have until at the second part of a sentence. So the difference is that the until will do that thing in the block first, and then it'll check for that condition after. So
no, yeah. So like the important thing, like we're going to give you an opportunity to try these things out on your own, and the idea is like play with that to see like to determine like exactly what it does. Cool. Awesome. Finally, we also have the last one. Loop do end. What's different between this one and the other loops we've shown before? Sydney? You are muted. Still muted. Did that help? There we go.
God, yes. I'm like clicking and doing nothing. Okay, sorry. Can you repeat the question one more time?
What's the difference between this kind of loop here and the other ones? What looks different about it?
So the other ones are telling you what that condition is that it's waiting to happen.
Yeah.
Or this one's just saying loop through the block.
Yeah. Yeah, and that's the thing is that this one has no condition in it. Like we could set it up so that it will kind of loop forever, and it will be up to us to kind of create that condition if we even want to have a condition, and you know kind of stop. We use the break syntax to do that, and something like that would look like this, right? We start with count with 0, we add 1 to the count, and whenever it hits this, it will break and stop that loop. Pro tip for you now, as you are creating loops for the first times, you will get yourself into a place where you create the wrong conditional or set it up wrong, and you get into what's called infinite loop. If you do this, Control-C will break you out of it. So you don't have to close your terminal or anything. Control-C, not Command-C, Control-C will stop a loop if your program gets into this loop. I just saw a hand disappear? That was the question answered?
Yeah, that was me. I was pretty much the question. If we were to run into an infinite loop, what's the fastest way to stop it? Just Control-C then?
Control-C. Yep. Control-C will stop that.
Thank you.
Cool. Vanessa?
What would be like why would we choose to, it looks more complicated to use this because you have to remember to put the break there. What would be a situation that we would choose to do that one and not the other ones?
It really depends. I think that like it's everything is so situational. There are so many reasons I'd use one or the other. I think for me, I generally stick to I generally try to pick enumerables to iterate over a collection. If I'm working with a collection, usually you use looping to iterate over a certain collection. There'll be circumstances where you do not. I think of how it fits in my head, how the conditionals fit in my head, how it makes sense to me internally, my choice between the while and until. I think that, I think for like the parking lot example, I think I would use until I find a parking spot. Until empty parking spot found, or whatever, however I want to call it. That makes sense to me in my head. You pick the one that makes sense to you in your head. It's probably going to be the best thing, the best decision for you.
Thanks.
Yeah. Other questions about conditionals, branches, looping? Cool. So if there are no more questions, I want to say two things. The first is that I am going to put in your channel the link to this lesson plan. There are some exercises and questions in here that I recommend you kind of go through some point today. Second, at 1 o'clock, is that the time? You have an independent challenge. We're going to give you an hour and a half to complete it. Keep an eye on Slack. We will be taking attendance via a Slack thread and instructions how to do it. So there will be no Zoom call for the independent challenge. What you'll be doing is you'll be forking and cloning a repo, doing whatever is inside there, and putting up a pull request. And you can DM instructors if you have any issues during that time, but essentially an hour and a half where you will take the time to kind of do this independent challenge. After the independent challenge is over the next 48 hours, the instructors will go through and give you feedback and give you a score on the independent challenge via GitHub. So keep an eye out for that, and that'll be you'll receive that within the next 48 hours. At 2:30, 2:30, is that on the clock? Yeah, 2:30, we'll allocating you a half an hour time for you to go ahead and reach out to your mentor if you have not already. If you already reached out to your mentor, this is time for you to go ahead and make sure that you have continuing that relationship with your mentor. Your relationship with your mentor is critical to your success at Turing. At 3 to 4 o'clock, you have PD work time, where you will, it's time for you to work on your career journal. And that will be due Sunday evening. Your career journal. So get that in because we want to be able to start checking and giving you feedback on your career journal as soon as possible. Cool. Any other questions about the rest of the day? Also want to add that between 3 and 4, instructors will not be available because we have a back-end meeting at that time. We have back-end meetings Wednesdays 3 to 4. Cool. All right. Have a good lunch.